Why is long-term potentiation key for brain plasticity? Have you ever wondered how our brains learn and adapt over time? One of the key players in this process is long-term potentiation, often referred to as LTP. This is a process that strengthens the connections between neurons, which are the building blocks of our brain. When neurons are activated together repeatedly, their connections, known as synapses, become stronger. This change can last from hours to weeks, making it a lasting adjustment in how neurons communicate. So, why is this important? Brain plasticity is the brain's ability to change and adapt based on experiences. Long-term potentiation is a vital mechanism that supports this adaptability, especially when it comes to learning and memory. When a baby interacts with the world, like hearing a parent's voice or seeing a familiar face, the neurons involved in processing those experiences fire together. This repeated activity boosts the synaptic strength, making future communication between those neurons faster and more reliable. A fascinating aspect of long-term potentiation involves a special receptor called the N-Methyl-D-Aspartate receptor. Normally, this receptor is blocked by magnesium ions. It only opens when the neuron has been sufficiently activated by prior activity. Once activated, it allows calcium ions to enter the neuron, which triggers a series of events that increase the number and sensitivity of another type of receptor at the synapse. This results in a stronger response to future signals. In the context of infant brain growth and early childhood development, long-term potentiation plays a vital role in shaping neural circuits based on experiences. As infants engage with their surroundings, LTP helps encode sensory experiences, motor skills, and early cognitive functions. This process reinforces the relevant neural pathways, which is essential for forming memories and acquiring new skills during critical developmental periods. Moreover, long-term potentiation does not work alone. It interacts with other forms of synaptic plasticity, such as long-term depression, which weakens synaptic connections. Together, these mechanisms allow the brain to fine-tune its neural networks, ensuring efficient processing and adaptability. This balance is especially important during early childhood when the brain is highly responsive to environmental input. Understanding long-term potentiation helps explain why meaningful interactions and experiences are so important for infant development. Activities like talking, playing, and responsive caregiving provide the repeated stimulation necessary for LTP to strengthen neural connections. This support is vital for healthy brain growth and learning. In essence, long-term potentiation is key for brain plasticity because it offers a lasting biological mechanism for strengthening synaptic connections based on experience. This process is fundamental to how the infant brain adapts, learns, and develops during early childhood by modifying neural circuits in response to environmental stimuli.